Hello everyone, welcome back. In this video, we are going to learn another important concept in Java multithreading, that is thread lifecycle in Java. So we will see with a clear explanation and practical examples. Subscribe to the channel to keep learning and growing your Java skills. Now let's get started. So you created a thread and called a start method. So the thread must be running immediately, right? Not necessarily. A thread can be ready to run, waiting for another thread, or blocked while trying to acquire a lock, sleeping for a specific amount of time, or already finished. And here's something that often confuses Java developers. If you check Java's official thread state.enum, you won't even find separate running state. So what exactly happens to a thread from the moment we create it until it finishes? So in this video, we will follow one thread through its complete life cycle and understand all 6 official thread states in Java. And along the way, we will see the important difference between blocked, waiting, and timed waiting differences. Let's start with the moment a thread is created. So Java officially defines 6 states in the thread.state.enum. What are those? Those are new, runnable, blocked, waiting, timed waiting, and terminated. So a thread can move between different states during its lifetime, depending on what is happening during execution. So one important point is that these states do not always follow one fixed sequence. For example, a thread may move between runnable and waiting multiple times before it finally reaches to terminate. So let's understand each state one by one. Okay, so we will start with a new. Okay. So the first state is what? New. So a thread enters the new state when we create a thread object. Okay. We have created a thread object, but we have not yet called the start method. So that state will be treated as new state. Okay. So let me go to the IntelliJ and show you. So let's say I am creating one thread. Okay, thread is what? Built-in class. I am creating just an object of built-in thread class, and inside that thread class, what we pass? The task. What task or work we need to do as part of this thread. So what we used to do earlier, we used to create separate class and implements runnable and override run method, and we were providing in that run method what task or work needs to be done, right? But instead of going that approach, we can use a Java 8 concept, that is a lambda expression. So in the new thread constructor, we can directly provide using lambda expression the run method implementation. Okay. So I will directly write here what needs to be done, what task or work needs to be performed as part of this thread. So I will simply print running. Okay, running means what? This thread is running. So whatever I have written inside this curly braces, this is like implementation of run method. Okay. So this work will be done as part of this thread. And as we have already discussed that each thread will do some task or work. Okay. So the first state is what? It is new. So a thread enters the new state when we create a thread object. So using new keyword, we have created a thread object, but we have not yet called the start method. Okay. So here we have created a thread object. At this point, a thread exists as a Java object, but it has not been started. Okay, if we call get state at this moment, Java returns new. Okay, I will show you. Thread dot get thread dot get state. So it will return the current state of the particular thread. Okay, so now let's verify it. See, so if we call get state at this moment, Java is returning what? New. So remember, thread object created, but start has not been called. This is the new state. Okay, now let's call start and see what happens. Okay, now I will call the start method, thread.start. Okay, so when we call start, again I will print the same line, getting state. What is the state of the start? Okay, so when we call start method, what it will do, it will call the run method implementation. A run method implementation we have provided here, that is running. So when I will invoke this start method, it will internally invoke the run method and it will execute this statement and it will print running, and post that I am checking what is the state. So let's see what is the state after calling start method. See, so when we call start method, internally it is doing this process, creating a new thread execution and calling the run method and executing the code inside run method. But during this process, we have already executed this line, and this line is telling it has moved from new to runnable state. Okay, so when we call start, the thread moves from new to runnable. Now here is very important detail. Many lifecycle diagrams on the internet show two separate states called runnable and running. But Java's thread.state enum does not define a separate running state. So in Java, the runnable state can represent a thread that is ready to execute or one that is currently executing in the JVM. So the actual scheduling of threads is handled by the JVM and the operating system. Okay. So calling start method does not mean that our code instantly starts executing at that exact moment, and that's why running is printed later. So it makes the thread eligible for execution, and this is why runnable is one of the most important state to understand correctly. Okay, so now next question is, where is the running state? Okay, so conceptually we often say that a thread is ready or that thread is running, and some diagram represents these as a separate states. Okay, runnable and running. But when we are talking specifically about Java's thread state enum, both are represented under runnable. So if someone asks you to list the official Java thread states, do not add running as the 7th state. Java officially defines 6 states. Okay. Now while our thread is runnable, it may encounter a situation where it cannot continue because another thread owns a lock. That takes us to the blocked state. Okay. So the third state is blocked. So a thread enters the blocked state when it is waiting to acquire a monitor lock so that it can enter a synchronized code. Okay, you imagine thread 1, okay, thread 1, let's say thread 1 enters a synchronized block. This is a synchronized block. Okay, think like it is a common resource, and multiple threads wants to use this common resource. Okay, and let's say thread 1, okay, thread 1 enters a synchronized block and acquires the lock. Acquires the lock means what? Thread 1 is using and it is logged. That means no other thread can use it. Okay, and now, so thread 1 is currently using it and lock is acquired by thread 1. Now let's say another thread, thread 2, is trying to enter synchronized code, but it is protected by the same lock. Why? Because thread 1 still owns it. So thread 2 cannot enter yet, right? So it becomes blocked. So once the lock becomes available, okay, that means thread 1 is done with his task and it will unlock this block. Okay, then thread 2 acquires it and thread can return to the runnable state. So earlier it was blocked. Now thread 1 has released this lock. Now thread 2 can acquire this synchronized block and thread 2 can move from blocked to runnable state. Blocked to runnable state. So the keyword for blocked is lock. The thread wants to enter synchronized code, but another thread currently owns the required monitor lock. Okay. Now, next state is waiting. We have the waiting state. A thread enters the waiting state when it wants indefinitely for another thread or some specific action to occur. Okay. So for example, object.wait. Object.wait without a timeout can place a thread into waiting, or thread.join. Okay, without a timeout can also cause the current thread to wait for another thread to terminate. Okay, we will see this in detail in the later part of this video, what is join. But for now, I'm just giving you a brief that without a timeout, it can also cause the current thread to wait for another thread to terminate. Okay, so let's say you have main thread, and inside main thread you are calling t1.join. So what will happen? Main thread execution will occur, and when this line will execute, main thread execution will go on waiting state. Why? So when this statement will execute, it is saying t1.join. That means main thread will wait until t1 completes its cycle of the multithreading, that is until it terminates. So after completion of t1 thread only, main thread will come again from waiting to runnable and it will execute the remaining lines of code. Okay, we will see later part of videos the join exactly. I have just given you a brief. Okay, and another example is log support.park. So the important idea here is that there is no specified waiting duration. We are not providing anywhere the duration, how much time it should wait. Correct? So the thread needs another event or action to allow it to continue. And this brings to an important question. If blocked and waiting, okay, we have earlier seen blocked state, right? So blocked and waiting both mean the thread cannot currently continue. Then what exactly is the difference? What is the difference between blocked and waiting? Because in both the case, thread cannot execute currently, okay, cannot continue currently. Then what is the difference? So let's see the difference, okay. Blocked and waiting. So this distinction or difference is extremely important. So blocked specifically means that a thread is waiting to acquire a monitor lock, okay, before entering synchronized code. So we have seen for blocked, there is a synchronized code and it is acquired by some other thread, and let's say by T1 it is currently acquired, T1 is currently using. So T2 cannot use it until T1 releases this lock, okay. So what T2 will do? T2 will be in the blocked state, okay. So currently it cannot execute T2 thread. It is in waiting, in blocked state. And waiting means what? Waiting means that a thread is waiting indefinitely for another action, waiting for another action or thread. I have given you one example of join. Okay, so for join, what will happen? So we have one main thread, and inside main thread we have written one line T1.join. That means main thread will wait until T1 thread is completed. So main thread will be in waiting state until T1 thread completes or finishes. That is another action, waiting for another action or thread. So remember the simple difference. Blocked means think lock contention, okay. Lock is happening. Some other thread is using and locking it. So T2 thread is getting blocked. And waiting means think like waiting indefinitely for another event or thread action to occur. So now what if we want a thread to wait but only for a specific amount of time? So this gives us the next state, okay. So the fifth state is timed waiting. So this is similar to waiting, but with one major difference. There is a time limit. A very common example is thread.sleep, and we here provide the time, the specified time. So if a thread calls thread.sleep for 2 seconds, it enters the timed waiting state for that particular period, okay. Other examples include wait, okay, wait, join, spark nano, spark until, okay. So once the waiting condition end or the specified time expires, the thread goes from timed waiting, okay, timed waiting to runnable state, back to the runnable state. So the easiest way to remember it is waiting has no specified timeout, but time waiting has the time limit, okay. So these, okay, timed waiting. Before moving to terminated, these three states are commonly confused. What are those three states? Blocked, waiting, and timed waiting, okay. So these three states are commonly confused. So let's make the difference very clear, okay. So if a thread is waiting to acquire a monitor lock, okay, thread is waiting for acquire a monitor lock, lock is there, then it is blocked, okay. And if it is waiting is indefinitely for some other action, okay, or other thread action, then think it is waiting. And if it is waiting with a specified time duration, then think it is a time waiting. So for block, think like lock, and here no time limit, it is waiting for another action. And for time waiting, think like there is a specific time. Okay, so if you remember these three ideas, distinguishing these states becomes much easier. Okay, now we will move on to the final, that is terminated state. So a thread enters the terminated state when its execution has completed. In other words, its run method has finished. Run method, what it will do? It will carry the task, what work needs to be done as part of this thread, right? So those tasks or work has finished, either normally or because execution ended due to an uncaught exception. So it might happen like, okay, it goes on the normal process and it completed its task, but there is another chance it can throw an uncaught exception. Exception might occur. So once a thread reaches the terminated state, the thread object cannot be started again. As we have learned in the previous video, calling start again on the same thread object results in an illegal thread state exception we have seen. So if we want another thread execution, we need to create another thread object. Okay. Now we will see, let's connect everything together. So thread begins in the new state when the thread object is created, but we have not called the start method. And after start is called, see here, after start is called, it moves to runnable. Which state? Runnable state. And during its execution, depending on what the program is doing, it may become blocked, waiting, or timed waiting. Okay, when the condition causing the state is resolved, a thread may return to runnable. Okay, so blocked, when it will go, some lock is happening, then it will go to blocked state. And let's say we are calling join method, or some thread is waiting for some other action and there is no time limit, then it will go in the waiting state. And if there is waiting is happening but there is time limit, then it will go to timed waiting state. And from blocked waiting or timed waiting state, it will again, once the lock is open for blocked state, once the other action is occurred for waiting, and once the time is finished for timed waiting state, it will again come back to runnable state. Okay, so these transitions can happen multiple times. And finally, when the run method completes, the thread reaches terminated state. So when run completes, it reaches terminated state or unhandled exception also. If it is throwing an unhandled exception, for that also it will reach terminated state. So the life cycle is not simply one straight line. A thread can move between several states many times during its lifetime. Okay. Now I will ask you one question. So I will remove this part and I will write here. I will use try catch block because try catch block is used for handling exception, right? So I'm writing here one exception, interrupted exception. Okay, and I'm doing nothing, I'm just simply printing e.print distractors, that's it. And here I'm writing thread.sleep for 5 seconds, let's say 5 seconds. Okay, so this is what I have created, one new thread, and inside new thread we are passing the implementation of run method. Run method means what task needs to be performed, what work needs to be done as part of this thread. So as part of so work is like it will wait for 5 seconds, and if any exception occur, it will throw an exception. This is run method implementation as part of this thread. Now I will call thread.start method. When I will call the thread.start method. Okay, thread.start method. So look at this code. We create a thread started, and inside the run method we are calling thread.sleep for 5 seconds. While the thread is sleeping, what state will it be in? What state it belongs to when we are calling start method, whether it is blocked, waiting, or timed waiting. Think about the rule we just learned. So there is a specific time limit, right? That is 5 seconds. So the correct answer is timed waiting. Now let's verify this directly using Java. So what I will write, the thread dot get state, and before get state I will simply write thread dot sleep for 5 seconds. Okay, and I have changed it to 10 seconds so that we can see the exact state. So what will happen? Start method will get called, and start method will call run method. That means this lines of code will get executed. Okay, so I am giving 5 seconds to happen these things so that we can get the state of the thread. Okay, so let's verify it. See, so there is timed waiting. So this is important because we are not just memorizing a lifecycle diagram. Okay, Java actually exposes these states through the getState method, which means we can observe the state of a thread while our application is running. Okay, now so let's quickly recap. Okay, what we have learned so far. So new means the thread has been created but not started. Runnable means the thread is eligible to run and may be executing. Blocked means it is waiting to acquire a monitor lock. Waiting means it is waiting indefinitely for another action. And timed waiting means it is waiting with a specified time limit, and terminated means execution has finished. But this raises another interesting question. Imagine we have 10 threads in the runnable states all ready to execute. Which thread gets CPU time first? Can we control which thread gets preference? And can we thread temporarily pause to give other threads a chance? That takes us into thread scheduling, priorities, and some of the most important methods available in the thread class. Okay, so that's all for this video. I hope you now have a clear understanding of complete thread lifecycle. Thanks for watching, and I will see you in the next video.